start. So welcome everyone. As I said, this is the very first ADS webinar, hopefully not the last. Just to give you a little brief overview of Amsterdam Data Science, we are a network organization that aims to bring together academia, industry, and society in the fields of data science and AI. We do this predominantly from our meetups. So usually we would be doing this in person, but we are using technology today to reach out to everyone we can. We have a really exciting program today. We have Jeroen Silvis, who's talking from the City of Amsterdam. And then we will be having a Q&A discussion with our moderators, Ayse and Hinda. Over to you, Ayse.
Thank you, Jen, for the introduction, and thanks, ADS, for supporting us. So a warm welcome to everyone, and thanks for virtually being with us today. With my colleague, Hinda Haned, we are delighted to co-host this webinar on this very challenging topic, responsible AI in practice, with a focus on fairness. So I'll briefly introduce ourselves as moderators and a bit comment on why we are doing this. So my name is Aysenur Bilgin, and I'm a researcher at CWI and a data scientist at Victor Davis. I'm interested in developing fact AI solutions in the real world. And my colleague, Hinda Haned, I'll be co-moderating with the session. She is a specially appointed professor in the University of Amsterdam, specially appointed professor of data science in the University of Amsterdam, and a principal data scientist at Ahold Delhaize. Her interests also lie in topics such as explainable AI and fairness, which we will be diving into today. A bit on our journey of how we are bringing this content to you. For almost half a year now, we've been wanting to produce and distribute content for data science practitioners who are in the wild, most probably like many of you out there, that you really need this practical information. And today's webinar is actually the first effort of this joint endeavor. And before I give the floor to Hinda, I would like to, that slide was supposed to be on. I would like to encourage every one of you to join the discussion on slido.com, our Q&A platform, and post your questions for our speaker on here. The instructions are on the slide right now, and we will be sharing questions later on. So Jeroen, I will stop my share now, and you can change while I give the floor to Hinda.
Yeah, thank you, Ayse, and thank you, John, for also facilitating this with Amsterdam Data Science. So I won't be talking for very long. I just want to introduce and welcome Jeroen Silvis, who is a lead data scientist at the Municipality of Amsterdam, and who was kind enough to find some time in his schedule to talk to us about the challenges that data scientists face when they apply machine learning on critical areas, such as welfare allocations, for example. So, Jeroen, the floor is yours.
Thank you very much. Thanks a lot for having me here. This is my first webinar as well, so I'm super excited. My name is Jeroen Silvis. I work for the municipality, and today I want to give you a little bit of an insight how it is to work as a data scientist for the municipality. What makes this a unique organization to work for, by giving you some examples, and it will be a reality check. It will show you guys that it is an extra challenging environment to act as a data scientist, but eventually I do hope that it will inspire you. Here we go. The City of Amsterdam. Well, it's actually, of course, a big city, at least to Dutch standards. We have 800,000 people living here in the city. But if you look at the municipality, the organization is actually huge. It is the biggest employer of the city. There are no other organizations or companies even that have hired more people. Myself, I work for the Department of Research, Information and Statistics, which is a department of approximately 200 people. And we have a very central part to play in the organization. We do a lot of research, like the name suggests, and we generate a lot of statistics about the city to get an idea, a grasp of what is going on, how the city develops, and more recently, we also have the responsibility to get more data that we have as an organization accessible, and to actually use and gain value out of this information, out of this data. And yeah, today I want to focus on the fact that we are not just an organization, because we are not a business enterprise. We have a special status, so to say. So if you start working here, one of the first things you have to do is take an oath, which is, I don't think, the case in many companies where you want to work. And this oath basically implies that you have to make certain promises, like don't blindly follow orders, always consider whether you're doing the right thing, also to trust your colleagues that are professionals, etc. So the fact that you have to do this already from the start, when you start working here, I think says a lot. And why is that? Why do we have to do that? Well, first of all, when you live in the city of Amsterdam, you cannot really choose. There are no competitors. There's only one municipality, so you have to do with that. And at the same time, this organization has a lot of special powers. It can give fines. It can give or take away permits. It can even put you out of your house if you have a very bad situation. You can do a lot of stuff as a municipality. So it gives you a lot of powers. And at the same time, we have a lot of responsibilities. Like we are responsible for the roads we have in the cities. We are responsible for certain social services. So taken all together, it means that working for this organization is not just like working for other organizations. But what does this mean for a data scientist? Well, quite a lot, I can say. But before we go into this immediately, let me give you some examples of really cool stuff that we're also doing. Like this really cool project, the data portal. What we do as an organization is also try to make data more accessible, not only for ourselves, but also for people outside our organization. And that's why we also built this website where you can find all kinds of data sources, data sets that you can just explore and just try and see if you find interesting stuff in there. And one of the data sets, really big ones that we have there is our panorama images. We've taken images of the entire city, like just like Street View Google has done. We collect these images ourselves, and this is actually more up to date than Google Street View is. And you can basically click on the map and take a look how it looks there. But we also provide all kinds of other information with that, like what kind of building it is, when it was built, etc. This is all real cool, interesting stuff that we just share and make accessible to everyone. Another really cool example, I would say, is the work of Maarten Sigel. He's doing a lot with image detection or object detection. He has a really cool GitHub page and other pages that I just showed, where you can just take a look at his code or immediately use his piece of software to download on your phone, walk around or cycle around in a city, and based on the images that you take, garbage is recognized and detected, and it will immediately send a signal to us such that we gain more insight where to find garbage in our city. Really cool project, I would say. But today I want to focus on the social domain, of course. And the social domain I want to focus on because it's particularly challenging and complicated. And I will explain that by 2 examples. But first of all, let me say that this is also a very interesting domain because there's a lot going on. One of the bigger projects going on right now is called Zicht en Grip op Sociaal, in which we try to make data accessible, but also in this domain. And that sounds perhaps a bit simple, but it's actually a huge challenge because in this city we have all kinds of social services. And here I show you some examples of services that are quite large. A lot of people use these. And it also means that we actually have specified specialized departments taking care of these services. So many of these services actually have their own registration systems and also systems to store all the data in. So there's not one huge database in which all this information is just there. We are actually trying to get this data accessible, try to restructure it such that we can interpret it and try to bring it together. And yeah, like every data scientist probably will recognize, when you bring data together, that's when it starts to become really valuable. And this is where we stand right now, I think, as a organization, that we are finally bringing all this data together and really cool applications start to become possible. Okay, now to the examples of real data science applications. Well, this first example is about social assistance benefit. I'm not sure if everyone is familiar with it. In Dutch, we call it bijstand. It's basically a basic income for people that don't have a job, but do, of course, still need to pay their rents and have to pay for their food, etc. So this is a service that makes people be able to still meet a certain living standard. This service is not assigned to only individuals, but sometimes entire families. And we as a municipality have a name for this, a customer. And I have colleagues at the organization and that help these people out. And one way to help them out is to reintegrate them into the job market. So basically, we try to help these people to get a job. And this is a really good thing, of course. But the problem is that these customer managers sometimes have very big caseloads. And that means sometimes that not everyone can be given the same amount of attention and the same level of service to get them to a job. And at the same time, some people may need a lot of help and others maybe not so much. So there is this situation in which we can make things perhaps more efficient, or we can perhaps assist a customer manager to do their job more effectively or more efficiently. So this is basically the business case of this first example. What kind of data can we use as a data scientist in this case? Well, of course, we have information of when these people applied for a social assistance benefit, an intake date. Usually we also know what age these people are, how many children perhaps they have, what level of education they have. And these are all features that you could perhaps use in order to get an estimation or a prediction of how likely they may be or when they will be able to find a job. And to make this situation easy, you could sort of consider that, when you sort of get a job within a year, then you get a 1. And if you don't, then you get a 0. And that way you have your label, the variable that you want to predict. Well, really common approaches in this case would be a logistic regression, random forest, or even a neural network. And that eventually leads to 0s and 1s of new data of people that come in, or you can come up with probabilities. And just to give you guys an idea, we use a lot of Python in our organization. We use Postgres to store data. And if we take things into production, we use Docker images, Docker containers. But how to approach this example the best way? First of all, you could really try to aim to optimize classification. You can try to come up with a model that is best able to make predictions. And in this case, you can really go for that because you could argue that it's in the best interest of everyone to provide this service as efficiently as possible, such that you can help as many people as possible. But of course, you may also argue that you have to be really careful in this case, because you may unwantedly be discriminating. If you come up with an algorithm or with a model that makes prediction, perhaps it takes certain features in certain cases that you don't really want, and that may be discriminating or something in a way that is undesirable. And there is also a third approach possible. You can also argue that besides trying to come up with a good prediction, you actually want to be able to explain why your model comes to certain predictions. Because if you would go and try to help person A and not person B, or to a lesser extent, you should be able to explain why you do that. And actually, that's the most important thing about this solution. Well, in practice, we eventually first went for the last approach, to just come up with a simple explainable model. And we did so by coming up with a decision tree model. And this decision tree model, like I described a few slides before, just took 0s and 1s of the cases in the past that eventually led to a discharge, or someone to find a job or not. But the results showed that you eventually can come up with groups of people with very high chances that they find a job within a year. Maybe even up to 90% or 95% chance of finding a job. And other groups of people may actually have very limited chances of finding a job. So it's, in a way, this model was a great success because it's really well able to find certain, so to say, target groups. But at the same time, you see that that some people had very high chances, some very low. And that led to the following problem. How should we use such a model now that we made a first attempt? Is this actually what we want to put in production and to let these customer managers base decisions on? Because what should we do with those people that have very limited chances of finding a job? Should we just ignore them to make our work more efficient? Just don't help them or something? I feel that that's not really what we should do. And at the same time, we also have people with really high chances to find a job. Maybe you can argue that you should not really help as much these people, because they inevitably they for sure almost will find a job. So yeah, by building a model, we made the situation more concrete, more clear. But now it's a matter of discussing what we should do with this, because I think the implications are quite strong. So for this example, I would say it's not always clear, and not to everyone from the start, what the real impact is of such a model. So yeah, that's something that you can really take from this. And the second thing is that just building a model that makes really good predictions, that's definitely not all there is. When you try to perform data science in this context, you also have to consider all kinds of other things. Then the second example, fraud detection. This is actually about the same social service, but now we focus on it with a different business case. First, of course, we have an applicant, someone who wants to use this social service. What we normally do when a new person applies, we make a basic check whether this person, for example, indeed lives in Amsterdam, indeed doesn't have enough income to provide the social living standard that they should have. And if this is all correct, then normally, we just give the social service, we provide it. But of course, there are some cases where you can find some suspicious things. And then normally we do some more investigations, whether this is really a valid case or not. But yeah, this is, of course, a balance between putting a lot of effort and time into this investigation, and at the same time still finding cases that are indeed not correct. And in this balance, of course, we can also use data science, and we can sort of assist colleagues trying to make better decisions on which cases to investigate and which cases not to investigate. Of course, with this example, I need to go to Rotterdam. They actually tried to do this before we tried anything. They built the Siri model, which was basically a model that really aimed for an optimal fit or an optimal prediction. And they used as much data about all the cases that they could find to really maximize their prediction accuracy. And their argument was, we as a municipality shouldn't really explain how we come to certain predictions, because then we would sort of reveal our investigation methods. So it's basically okay to make it a black box. Well, maybe some didn't really know, but this led to a lawsuit, of course. This is not really the way to do it. And one really important aspect of this problem was that they couldn't guarantee that this model that they built was not fair. You should really take care of fairness also when you build a model like this, because there may be a huge selection bias in there, which causes certain features that perhaps are not explicitly there in your data set still to be picked up by the model, such that it bases predictions on that. For example, somebody's background, somebody's migration background. There was no control over that. Another really important issue was that there was no public discussion about these features. And yeah, so no real control over them as well. Well, fortunately, we had Rick van Helwegen, and he was going for an internship here in Amsterdam, eventually ended up working for CBS. He was a graduate student from the University of Amsterdam, and he tried to figure out whether there are technological solutions to the fact that there may be certain features that you don't want your model to base predictions on, whether you can control that and whether you can do something about that. And he basically developed a fair trade model. If you want to look into it, just take a look at his thesis. You can find it on the website I refer to here. And yeah, it's basically a technique that uses autoencoders to be able eventually to take out certain causal effects that you don't want your model to use. So it all starts with a causal graph that you have to design, and then you use the data to fit this graph basically, and then once you have this graph, you can take parts out of it such that you can sort of make it operate without using those sensitive features. And what he showed is that this does make your model predict perhaps a little bit less accurately, but at least it makes it a lot fairer. And right now we have two interns from the University of Amsterdam that actually continue on this work. Really interesting stuff. We have Tim Smith, who is actually trying to come up with a technique in which you can with which you can test whether causal graphs make sense, whether they fit the data or not. Because nowadays you do need to build those graphs yourself based on domain knowledge alone. And Tim will hopefully be able to test where these models fit the data or not, are correct or not. And then you have Josje, who is trying to come up with a framework in which you can actually evaluate fairness, which is really important because there are all kinds of metrics out there, but there's, for me at least, no real overview or clear scheme of what you should use when you try to make your algorithms or your models fair, or at least evaluate that. So from this example, there are two lessons I think you should learn. I think data science does go hand in hand with ethics if you consider the work of Rick. And I think what is also really important here is that you should always be really transparent as a data scientist. What you do should make other people really involved in your work, and should allow them to have a discussion with you also which features you should use, which not. This should be something that you can openly debate. And I think, it's crucial to collaborate. Don't do stuff yourself and just try to figure out how things work or anything. No, always collaborate and try to find experts, people that can help you out, and that makes a huge difference. So because this is a webinar, not a real presentation, instead of some take-home messages, some stay-home messages, I think the city is a very, very interesting place to work. Or the municipality is an organization that is really, really interesting, particularly the social domain. We are bringing together a lot of information, a lot of data, and I think that is really valuable if we could sort of put that to use. But it is a very complex environment, of course, to operate in. So keep collaborating, and we may be able to get some real value out of it. Thanks a lot for your attention.
Thank you, Jeroen, for the inspiring talk. Now we will take some questions. Let me also open my camera. There were some questions actually during your talk. I'll first start with those. One of them is actually asking, let me also share my screen so that I can share the questions. And meanwhile, we encourage everyone to vote on the questions so that we can address those that you really want to learn about. Yeah. So here is actually the latest question at Jeroen. Can you share how Gemeente Amsterdam compares with other gemeentes and data science projects? And you mentioned on the Rotterdam with the Siri case, but would you like to elaborate further on that?
Yeah, the most crucial tip I would say is to be open about your work, be able to explain what you do, be transparent, because it's really important to give people the idea that that they are in a way in control over what you do. Because yeah, as a data scientist, I think people already have a certain suspicion. They think that you are only focused on the algorithms, about the optimization, and yeah, to really have an impact, I think, and to be able to yeah, to get things done. I think it's important to get everyone involved, and one of the most important things to do that is to be open to keep discussing the stuff that you do. So I think that really stands out.
Well, thank you, Jeroen. I'll read the next question for you. It's because it's one that I'm particularly interested in. So how about training different models for different groups, assuming that these models have comparable performance with regards to both accuracy and fairness? I get asked this a lot when I give my talks about fairness and accountability and why we should try and think about it in the broad context of their impact on society. So yeah, so what's your take on this? Would this work? Training different models for different groups?
I'm not entirely sure. I think you should. I'm not entirely sure if you then are in control over what you do. I think it's better to initially try to treat everyone the same, and then make sure that the technique that you use first of all is evaluated, so that you know what the outcome is, and yeah, that you are able to sort of evaluate whether that is fair or not. But then try to use that or adjust that technique that you use such that the outcome becomes fair. And I'm not sure if you train different models for different groups, that you are fully in control, and that yeah, that will come to a good solution. And that's something that I really like about the work of Rick, because with that technique he does show that he is in full control, even in cases where you don't have all the variables there. If there are certain effects, variables that you don't have data of, the latent variables, he still shows that he has yeah, is able to balance stuff. And
Yep.
yeah, I think that's a really particularly neat technique.
Thanks. Let's go to the next one. So I think there are 3 that have the same number of votes. So let's take the one in the middle. What is your take on progress in the fact AI field? Are there any blind spots? And I think FACT stands for fair, accountable, confidential, and transparent AI.
Yeah, I'm not entirely sure if I'm the right person to ask that question. Yeah, right now I don't work for a university. I'm not that super involved in the literature, so maybe I'm not the person to judge that.
All right. Okay, so what do we have next? Ice, can you take over so that I can also look at the questions that we're getting on the Q&A on Zoom? Yeah. We would prefer, guys, if you post your questions on Slido, because then everybody can see them.
Yes. And if you vote, for example, I see new questions being asked, but they are kind of at the end of the list and which doesn't show on the slides. So if I look at the top questions here, the first one is, what is your take on the relative importance of explainability in the light of GDPR? Would you like to have a go, Jeroen?
Yeah, well, I'm not sure what I can say about this. I think
sorry to interrupt you, but I was wondering if we could think about this in the light of the fairness kind of objectives of a model, because obviously your talk wasn't about explainability, but we could think of what are the frameworks that we can think of or we could develop where we would explain maybe some metrics related to fairness in a way that stakeholders and decision makers can understand. And yeah, of course, this takes an important part of in GDPR, but would that help?
Yeah, I guess so. Though in the context where I work, I think explainability, first of all, is important just to get a certain trust, to get people to trust your technique and trust your model, trust that the solution that you build is correct and works. Especially in the social domain, there are a lot of people that have a lot of experience of things that go on. Like, for example, in fraud detection, there are people, colleagues of mine, that have been investigating cases for like 30 years and have a lot of experience. And one of the really important things I think is, if you come up with a model that sort of assists their work, it's really important to be able to explain how your model comes to predictions, and especially when your model comes with predictions that don't always meet the predictions that these domain experts would have. So that's one important thing about explainability. And then there's also this aspect of, in particular in the case of fraud detection, that if you decide that you go and investigate a certain case, you cannot just say, oh yeah, we're gonna investigate this case because the model says that you have a label 1. Also in that case, it's really important that you are able to explain why a certain case has a higher risk of fraud. And yeah, you should really be able to explain that. So those are really important aspects of explainability as well. And then, of course, you have fairness. And yeah, I guess explainability may also offer a solution to gain control over fairness when you build models and try to control things. So yeah, those are all important aspects, I would say.
Thanks. What I would say about this, given that I work in industry and also in a research environment, is that indeed explainability has a huge part in GDPR. And even if fairness also had a huge part in GDPR in the way we're talking about it today, I feel like there is kind of a gray area where we need to figure out as data scientists how to apply that in our day-to-day work, because it doesn't really tell us what to do. There are many ways of explaining things to people. There are different people involved that probably require different types of explanations. So to me, it's taking an important part into the GDPR, but that does not mean that it's making things more restrictive or that it's helping us make the right decisions as data scientists. Servicing clients or stakeholders. And I see a very important link to fairness actually when it comes to explainability. To me, it's not really two separate buckets. The way I think about them is this is all about trying and being accountable and responsible in the way we design AI kind of based products. We need to think of different dimensions. And one thing that I find interesting about fairness is that it's often hard to explain to people why fairness is important and how it is kind of to be interpreted in a particular context. And also there was another question that was there earlier that relates to this, which is, for instance, why do you care so much about gender, for example? Why don't you just train one model per gender and then you'll be done? Well, it's not that straightforward because the bias in the data exists whether you train on genders at the same time or separately. And this is kind of all intertwined. And I just wanted to give my thoughts about that particular question. Okay, so I think our next most highly voted question, Ais, do you want to take over?
Yeah, sure. So which is actually the first two questions are kind of in line in what we've been discussing. So first one from Kim: how can you be open about your work when others speak a different language from you? How to bridge the gap between data scientists and non-data savies? And I think it also connects with the communication aspect that you also mentioned, the impact of the models during your talk, how it's perceived. How do you think we can best educate non-data scientists about the dangers of biases in AI models?
Yeah, shall I first try and answer the first question? Yeah, it's really challenging to bridge that gap. It's not only a matter of speaking a different language, but it's also a different way of thinking, I would say, that needs to be influenced. Because it's really hard to convince people that if at least if they have a lot of experience on something, that something as a model can actually outperform or do better than they can. So there's always this idea that they just don't believe it, and that holds for people on the work floor, but also for managers and people that make policies. There's always this idea that you first need to fully understand a certain problem before you can apply something like data science. It's really challenging. But I think one of the things that worked for me is to come up with really good examples of cases where it does work, and use those examples to explain why it works and how it works. So you need some success stories, some success cases. That helps a lot, because then you can really discuss this with someone who isn't necessarily familiar with the possibilities, with what this technique can do and what it cannot do. And the second question was, what kind of fairness metrics or trade-offs are we being challenged with in public domain? Well, one trade-off I would say is a trade-off between individual fairness and group fairness. Those two concepts aren't necessarily the same. If you have very homogeneous groups of people that you want treated fair, then group fairness, of course, is a good way to show that. But if these groups are not really that homogeneous, then you may try and correct for group fairness for being how to explain that? Then you may try to come up with a number or a measure of how well your model is able to treat these groups equally. But if you take two cases of people from different groups, but these groups are really heterogeneous, then it could be that they are quite the same nevertheless. And so then group fairness is not the best metric. So I think that's an example where two matrices can actually show different things, even though you're in the same cases try to get an idea of fairness.
Yeah, I guess all these questions require you to give another 20-minute talk, perhaps, but we're out of time. And
they're great questions, though.
Yeah, they're really great questions, and we have a lot of them. But I'm sure this will also give us inspiration on what to pursue to address these questions. I think, Jen?
Yeah.
Well, thank you everyone for joining us for this webinar. Thank you, Jeroen, Hinda, and Ayse so much for participating. I think we will be continuing the Slido for another couple of days. So if anyone has any more questions, please do ask them. And we hope that this is actually the first of a series of webinars, or in fact meetups when we're so committed, on ethics. So if you have any other topics that you are very interested in, please let us know. But yeah, for the time being, thank you so much for joining us.
Yeah, thanks everyone, and keep the questions going. And as Jan said, the idea is to get some material and some questions to organize more of these and maybe do it longer. We didn't want to bore you too much, so we aimed for 45 minutes. But now I think we realize we could have talked about this for a couple of hours. So maybe let's just plan things accordingly next time. Thanks everyone. Thank you, Jeroen. Thanks so much for your time.
And just one last thing. We've recorded this session, so we'll be posting it on the ADS website for everyone to rewatch should they want to.
Thanks everyone.
Thank you so much. Goodbye.
Bye.
Bye. Take care.